Imagine standing on the edge of the earth, staring into the abyss. Does that seem far-fetched to you? Picture this. You're there, the edge of everything you've ever known, peering into nothingness. It's a perspective that challenges our fundamental understanding of our world. It's the seat of a debate that has intrigued and baffled humanity for centuries. Is the earth flat, or is it round? Stay with us as we delve into this fascinating debate. The shape of our world is not as simple as you might think. The flat earth theory, dismissed by many, embraced by some. But what does it actually entail? Let's delve into the depths of this intriguing belief system. The flat earth theory posits that the earth, rather than being a sphere, is a flat disk. This concept dates back to ancient civilizations like the Babylonians and Egyptians, who depicted the world as a flat plane. However, it's important to remember that these civilizations also had their own cosmological models that were far more complex than just a flat plane. Fast forward to the 21st century, and the flat earth theory has seen a resurgence, largely driven by the internet and social media. Key proponents include figures like Mark Sargent and Eric Dubay, who have amassed large followings with their bold assertions and thought-provoking arguments. So, why do these modern flat earthers believe in this theory? Well, the reasons are as varied as the believers themselves. Some point to perceived anomalies in NASA's images of Earth, while others argue that the horizon appears flat to the naked eye. There are those who believe that gravity is an illusion, and that the world is actually accelerating upwards. And then there are those who, in a world filled with misinformation, find comfort in questioning the accepted truths. It's important to note that these beliefs often go hand in hand with a deep mistrust of authority and the scientific establishment. For many flat earthers, the theory is not just about the shape of the Earth, but a way to challenge the status quo and seek their own truth. Despite its dismissal by the scientific community, the flat Earth theory remains a fascinating study in belief and skepticism, a testament to the human capacity for curiosity and doubt. As we navigate through the vast ocean of knowledge, it's essential to approach all theories, even those deemed unconventional, with an open mind. So there we have it, the flat Earth theory in a nutshell. But how does it stand up against the round Earth theory? Now let's turn our attention to the dominant belief, the round Earth theory. As far back as the ancient Greeks, humans have theorized that our planet is a sphere. This idea, known as the round Earth theory, has held sway for over 2 millennia. But why is this belief so prevalent? Well, it's all thanks to a combination of scientific evidence, observational data, and mathematical calculations. The first person to suggest a spherical Earth was the Greek philosopher Pythagoras, around the 6th century BC. Over the centuries that followed, more evidence piled up. The way ships disappear over the horizon, the round shadow the Earth casts on the moon during a lunar eclipse, and the way the stars change as you move north or south, all suggested to ancient thinkers that the Earth was round. Fast forward to the 15th century, and explorers like Ferdinand Magellan and Sir Francis Drake circumnavigated the globe, providing further proof that the Earth is round. In the modern era, we have images of our planet taken from space, which clearly show a round Earth. But it's not just observational evidence that supports the round Earth theory. Mathematics and physics also play a key role. For example, the laws of gravity, as described by Sir Isaac Newton, work best when applied to a spherical Earth. And then there's the science of geodesy, which studies the Earth's shape, size, and gravitational field. Geodesy also points to a round Earth. The round Earth theory is widely accepted because it's backed by a multitude of disciplines, all converging on the same conclusion. It's not just one piece of evidence or one scientific theory that supports the idea of a round Earth. It's a whole host of them, working together to provide a comprehensive picture. So there you have it, the round Earth theory, backed by centuries of scientific observation and mathematical evidence. It's a theory that stood the test of time, providing a framework for our understanding of the world and our place in it. The round Earth theory, backed by centuries of scientific observation. But is it truly infallible? 2 theories, 1 Earth. How do they stack up against each other? Let's dive right in. On one hand, we have the flat Earth theory. This theory suggests that the Earth is a flat disk, with the Arctic Circle in the center and a wall of ice known as Antarctica forming the perimeter. This perspective challenges our understanding of gravity, suggesting that objects are not pulled toward a mass, but rather are pushed downward by a mysterious force. It also posits that the sun and moon rotate in circles above the flat Earth, creating the illusion of day and night. On the other hand, we have the round Earth theory, or more accurately, the oblate spheroid theory. This is the model accepted by the vast majority of scientists worldwide. It explains gravity as a force pulling objects toward the center of mass, which aligns with our everyday observations and experimental data. It also accounts for phenomena like the changing seasons, the different constellations visible from different latitudes, and the way ships disappear over the horizon from bottom to top. Now let's weigh these theories against each other. The flat Earth theory, while fascinating, struggles to provide satisfactory explanations for a multitude of natural phenomena. For instance, how does one explain lunar eclipses, or why different stars are visible in the northern and southern hemispheres? It's also worth noting that no credible visual evidence of this flat disk or its edge has ever been provided. On the flip side, the round Earth theory, backed by centuries of scientific observation and exploration, offers a comprehensive explanation for the world as we perceive it. It's supported by a plethora of evidence, from the images of Earth taken from space, to the way gravity works, to the very fact that we've circumnavigated the globe countless times. In terms of cultural and social implications, the flat Earth theory, although largely dismissed by the scientific community, continues to intrigue a subset of people, sparking conversations and debates about the nature of scientific truth and the power of belief. As we've seen, both theories present compelling arguments, but ultimately, the shape of our world is not a matter of belief, but of scientific fact. So where does this leave us? What shape does our world take? We've journeyed through the theories from flat to spherical and confronted the contrasts. The debate endures, but the value of scientific evidence remains paramount. It's the compass that guides us through the maze of conjectures. As we continue to explore and understand our universe, we must keep our minds open to new possibilities. But remember, an open mind isn't an empty one. It's filled with curiosity, questions, and the relentless pursuit of truth.